Science Unplugged, the podcast where science and conversations collide. Join us for a deeper look into the world of innovation. We are your hosts, Charvi Trivedi.
And Taslima Farooq. Let's explore the insights from the world of science. From the lab to the field, we'll dive into the stories and experiences of researchers, experts, and innovators who are shaping our understanding of the world.
Hello, Dr. Arghya. It's an honor to have you today. Dr. Arghya
Argo.
is
Yep.
a systems neuroscientist and a pathway to independent scholar at Tufts University. He has an impressive portfolio which tracks from a JRF to a postdoc, and his profile also reveals a great academic background. We are very excited to go deeper into this conversation with you, sir. Hope you are ready for some brain picking.
Thanks. My parents are doctors, and so once I realized somewhere around high school that I did not want to be a pediatric cardiologist, and I wanted to do more fundamental exploration of science, I started looking for programs where I could get the kind of background knowledge you would need to pursue neuroscience, and that's what I was interested in, neuroscience, because I mean, it's the only organ. If you think about the brain is the only organ in your entire body that can wander about itself. That's quite a feat, right? Your liver cannot do that. Your kidney cannot do that. I mean, and sure, it has all these cool features of memory and like decision making and all that stuff. But that aside, so that's at my fundamental growing years in high school. That's why I was interested in the brain. Like this is this organ that can think for itself. I don't know anything else in biology that can do that beyond the brain. So, so I was looking for a program that would allow me to study the brain, and I realized early on that you need a very diverse set of skill sets from biochemistry to molecular biology, cellular biology, all the way up to electronics, and quite a good sort of fundamental understanding of mathematics at university level. So, and I saw at that point this beautiful course that started at the Institute of Bioinformatics and Biotechnology at University of Pune on both bioinformatics and biotechnology, and they really covered a whole breadth of subjects. So that's where I went. So after getting my master's, I was looking for research experience, and then that's what I said. Serendipity plays a big role in it, right? Because while I was about to finish off my master's, not about to, like in the middle of my course, ICER came up in Pune. So a whole bunch of new faculty came. They were looking for people, right? So that led me to a research assistant position with Arnab Ghosh and Nishikant Subedar at ICER Pune, where I looked at zebrafish, their learning, specifically their olfactory guided behavior, because when we the whole idea of that was that when you are navigating an environment, how you interact with sensory cues are dependent on your internal state, and we were studying it from the perspective of olfaction, that when you're hungry you interact with food odors differently than when you're not. I mean, you can think about that in your own life experiences. When you're walking down a street, if you're hungry, you will notice every smell of food coming from different restaurants. You won't when you're not hungry. So that's what I was trying to study, like how our internal states drives our sensory processing, and I was using zebrafish. So from that, I got interested into learning and memory, and I've always been a pretty avid hiker, so I've always liked mountains, and in general, I've liked mountains. So I was trying to marry these two sort of interests. That led me to the laboratory of Professor Pico Caroni at Friedrich Miescher Institute in Basel, Switzerland, who was studying learning and decision making. And while I was in his lab, he started to sort of his primary interest was learning and memory. He started getting a bit more interested into how we form memories of rules of the world, not simple associations, not like stimulus A leads to consequence B, but how we generalize these across multiple stimuli to make abstract representations. For example, it's not that individual odors are related to food, odors in general relate to food. So that's an abstract rule, right? So that's what he was trying to get, he was getting interested in. So I started following that up under his supervision during my PhD. And so that got me into this. So that got me into sort of rule learning. From rule learning, it's a very straight, linear path to decision making. And when you're looking at decision making, having two doctors as my parents, I always want to think about it, how it applies to human health and disease. That took me to schizophrenia, because schizophrenia is primarily a decision making deficit. So then I tried to marry these two. And at that point, again, serendipity came in. Mike Halassa, who's my professor, who's my postdoctoral mentor here at Tufts, he came to give a talk. And I found that that's exactly what he's doing. He's studying decision making with some interest in schizophrenia. So I came to his lab initially at MIT and now at Tufts. And now I'm about to start my own lab at University of Pennsylvania. So that's pretty much the journey.
That's quite interesting. So we're just curious as to what prompted the shift from biotechnology to neuroscience, and why specifically neurophysiology.
I don't think it's a shift from biotechnology, because biotechnology is not just one field. It's a set of sort of techniques that applies to biology, and you can use those techniques to, I guess you can say, the unifying factor is that you try to implement a whole bunch of molecular, cellular, and a lot of mathematical uh, fundamental science to create technology and engineering in the field of biology. That's what biotechnology is. And I would say the brain is pretty much one of the last frontiers in which we really do not have much engineering done. I mean, if you look at most mental disorders and the drugs that we have for them, they have been developed in the 50s. And everything that has been happening since then are just modifications on the theme. Yet mental health disorders are just continuously on the rise. And we literally have no ways of treating them. Okay, right? So, so the field is ripe for implementing fundamental biological knowledge to devise novel techniques, be it non-invasive neuromodulation, be it non-invasive neuromodulation to target drugs to specific parts of the brain. This is what we need to do to break into the next frontier of mental health uh, therapeutics, and that's where the two fields get married. Like you have fundamental neuroscience knowledge, and you have knowledge of how biology works at the level of neurons, because that's the advantage of knowing fundamentals biology, be it molecular or cellular, because neurons at the end of the day are still cells. They still have conserved machinery. They just utilize that machinery differentially. So if you can figure out which part of the machinery inside the neuron goes wrong, then you can start targeting it. So there's the added complexity that the neurons actually talk to each other. That gives rise to a completely different type of interaction. But this is not sort of unknown. Our immune system does the same thing. We have a whole bunch of different cell types that has to talk to each other to give rise to this sort of holistic immunity that we have. And you cannot meddle with one part without meddling with the other part. So this kind of principles also apply for other parts also. So essentially my point is that biotechnology is sort of a skill set. What you apply to is the scientific field. And so the direction I want to apply to it is in neuroscience, because I see that that's where there's a lot of room for development.
This is really a fresh perspective of biotechnology and mental health. We've never heard of somebody associating those two together. So that
Well,
was really
thank
good to hear.